Chapter 22, Chemistry Theory Video 2. So now we are going to figure out which order of the reaction we are going to the equation would have. So to identify the order of reaction, there are three ways that we can do it. First one is by plotting a graph of reaction rate against concentration of the reactant. Reaction rate against the concentration of reactant. And then the second one is concentration of reactant against time. And then the third one is deducing the half-lives from graphs of concentration against time. Now what we can do is we can first consider the first one, that is the graphs of reaction rate against concentration of the reactant. So this will give us, depending on the slope or the shape of the curve, it will give us 0, first, second or third order of a particular reactant. So that means either to that particular reactant or the overall. If it is more than second order, it is actually rare, but we need to, if we can know which order the 0, first and the second order are, so then it is going to be sufficient for your examination. Now if you draw the reaction rate that is mole per cubic decimeter per second unit against the concentration of the reaction, that is mole per cubic decimeter, you will get three, depending on the order, there are three possible curves that you can have. The first one is 0 order, means a straight line that is parallel to the x-axis. So this is the first order, 0 order line. 0 order is parallel to the x-axis. Then first order is going to be a straight line which is not parallel but originating from the 0 point, originating from it comes from the origin, and it is not a it is a straight line, but it is not parallel to x or y axis. Then if you get a curve coming from the origin, then once again it is going to be the second order. Once again you will have to look at where it is going to originate from and whether it is a curve or a straight line. If it is a straight line but parallel to x-axis, then it is going to be 0 order. Then obviously it is going to be higher up, it is not going to start at 0. Then if it is coming from the origin and if it is increasing, but if it is a curve, if the rate is increasing, then what happens is it is going to be second order. If it is a straight line, it is going to be first order. So depending on the shape of the curve, you will be able to figure out which order it is going to be. Now in a 0 order reaction, if you take 2 ammonia gas, when pass through hot tungsten, would convert itself into nitrogen and hydrogen gas. So the rate is going to depend on KNH3 to the power 0. So when you plot the reaction rate against concentration, it is going to be a straight horizontal line. So that means the rate does not change with concentration. That means for 0 order reaction, K is numerically equal to the reaction rate. So the rate is equal to K. That because the concentration has no effect on the rate of the reaction. The rate is K, means because the NH3 to the power 0 is going to be 0. Any number to the power 0, power 1 is 0. Now when you get first order reaction, rate of the reaction is obtained. Now you can take 2N or N2O nitrogen monoxide when passed through gold, turning into nitrogen and oxygen. Then we have the rate equation. Rate equals Kn2O to the power 1. So that can be power 1 is written as itself. So if you draw that, it is going to be an inclined straight line going through the origin. So that means the rate is directly proportional to the concentration of N2O. So if you double the concentration, the rate of the reaction will also double, right? So that is that is what you understand. And also the graph would give you, if you draw the if you plot the reaction rate against the concentration, it is going to be an inclined straight line. Then if you draw the second order reaction, if you have a second order reaction, so it is going to be, now for example, NO2 plus carbon monoxide giving NO and CO2. The rate equation would be rate equals KNO2 to the power 2. So if you plot the graph reaction rate against the concentration, it is going to be an upwardly curved line. So here what happens is, it is the rate is directly proportional to the square of the concentration NO2. So that means if you double the concentration of NO2, the reaction would increase by fourfold. So we can see that if you compare if you compare the rate at 1 mole per cubic decimeter, that would be K into 1 squared, that is 1K. Rate at 2 mole per cubic decimeter, then K2 squared, that is going to be 4K. So that is, that is how it multiplies. I hope it makes sense. You will have to do question number 4, but before that, let's write down a note on this. Write down the order of a reaction can be identified in 3 ways. Number 1, plotting a graph of reaction rate against concentration of reactant. So we will write the note about that first, and then we'll go to the second one. When this graph is plotted, depending on the order of the reaction, we will get one of the below 3 curves. So draw this graph. After that, pause the video, draw it, and then underneath that write zero order reaction, 2NH3 gas, arrow on the top of the arrow, hot tungsten, N2 gas plus 3H2. By experiment we get the rate equation. Rate equals K within brackets, square brackets, NH3 to the power 0. That means the reaction rate does not depend on the concentration. Therefore, by changing the concentration, we cannot change the rate. Therefore, rate is equal to K. Then first order reaction, 2N2O gas, on top of the arrow write gold, 2N2 gas plus oxygen. Rate equation equals K, rate equals K N2O to the power 1. This means the graph would be an inclined straight line going through the origin. This means doubling the concentration of N2O will double the rate of the reaction. Second order reaction, next topic, NO2 gas plus carbon monoxide giving nitrogen monoxide plus carbon dioxide. Rate equation K NO2 to the power 2. When the graph is plot, an upwardly curved line would be the result. The rate is directly proportional to the square of the concentration of NO2. That means when concentration of NO2 is doubled, the rate increases by fourfold. I hope you understood. If you did not, please ask questions. If you did, please do question number 4.